So this question was asked in GATE 2017 Electronics and Communication Engineering paper set 1, in which you have given an ideal low pass filter whose input is x of t and output is y of t. X of t is your wide sense stationary random process with power spectral density s of x of f. Also, you have given the frequency response of this ideal low pass filter as h of f, which is equal to 1 when mod of s is less than equal to 1 by 2 Hz and 0 when mod of f is greater than 1 by 2 Hz. So you have given three statements. One is E of expectation of x of t equal to expectation of y of t, and the second one is expectation of x square of t equal to expectation of y square of t, and E of y square t equal to 2. So you need to choose the correct statements from these three. So the NPTEL reference for this question is Probability and Random Variables by Professor Aditya Jagannatham. You can find the reference in the lecture number 15, which is transmission of WSS random process through LTI system. So coming out to be the useful data slide. So the first useful data for this question is if x of t is wide sense stationary, then its mean will be constant. So that means that mean will be not depend on time, not depend on time t. So this is the first useful data, and the second useful data that if you have given h of t, that is linear time invariant system, and if you give input as x of t and you get output as y of t, where x of t is your wide sense stationary process, then you can write y of t as x of t convolution with h of t, or you can write this convolution integral as y of t equal to integration from minus infinity to infinity x of t minus tau h of tau d tau. Or when you take the e operator on both sides, then you will get e of y of t, that is the mean of y of t random variable, and this e will be minus infinity e into minus infinity to infinity x of t minus tau h of tau d tau. You can take this e operator inside this integral, then it becomes minus infinity to infinity e of x of t minus tau and h of tau d tau. So your x of t is a wide sense stationary random process, so the mean will constant as mu of x, that is mean will be not depend on time, so its mean will be also constant whether you advance the x of t or delay the x of t. So its mean is same as mu of x. So your expectation e of y of t becomes e of x of t, where this e of x of t is constant, that is mu of x will not depend on time, and this integral become minus infinity to infinity h of tau d tau. So this is also constant because it is not depend on time t, so it is also becomes constant, and its value is given as h of 0. So because your h of f can be written as minus infinity to infinity h of tau e to the power minus j 2 pi f tau d tau. So when you put f equal to 0 in this expression, it becomes h of 0 equal to minus infinity to infinity h of tau d tau. So this way you can write e of y of t equal to e of x of t into h of 0. So this is your second useful data. Now the third useful data is s of y of f is given as mod of h of f square, that is PhD of y of t as mod of h of f square into s of x of f. So this is the third useful data, that is the PhD relation of the input and output. And the fourth useful data is E of x square t, that is mean square value of random variable x of t, is given by integration of PhD, that is area under PhD, will give you the power or mean square value, that is minus infinity to infinity s of x of f df. So this is the mean square value. Whether if it is y square of t, then it becomes s of y of f df. So these four are the useful data for this question. Now coming to the solution, you have given h of f as minus 1 by 2 to plus 1 by 2. So this you have given in the question, and its amplitude as 1. This is your h of f, and this is your s of x of f. So this is your s of x of f. So these two data you have given. Now this x of t is passed through this filter h of t, whose impulse response, and the frequency response is given as h of f, and you get y of t. So this is the question. In the question you have given, so the first statement is given as e of x of t equal to e of y of t. So this statement you have given, the first statement you have given. So from the useful data slide, you can write e of y of t as h of 0 into e of x of t. We have derived this expression in the useful data slide. So you can put h of 0 equal to 1. So you will get e of y of t equal to e of x of t. So the first statement is the correct statement. Now coming to the second statement, the second statement is given as e of x square of t equal to e of y square of t. Now what is the e of x square of t? E of x square of t is nothing but area under PhD, that is from minus infinity to infinity s of x of f df. X of f is given as this function, that is e to the power minus mod of f. So this is you have given s of x of f. So from minus infinity to 0, it will be e to the power plus of f, and df plus 0 to infinity, it will be e to the power minus f d of f. So when you solve this integral, you will get e to the power f minus infinity to 0 plus e to the power minus f into minus 1 integration from 0 to infinity. So it will be 1 plus 1 equal to 2. So your e of x square t equal to 2. Now when you calculate e of y square of t, e of y square of t, which is area under s of y of f df. But this is not given. However, you know the relationship between the PhD of output and PhD of input, which is h of f square into s of x of f df. So h of f square you put equal to 1, because your h of f is given as minus 1 by 2 to plus 1 by 2, and this amplitude as 1. This is your h of f. So when you square it, it becomes 1. This is your h of f square equal to 1. Also the limit will be from minus 1 by 2 to plus 1 by 2. So this limit becomes minus 1 by 2 to plus 1 by 2, because your h of f is lying from minus 1 by 2 to 1 by 2, and the value is 1 into s of x of f df. So you can solve this integral from minus 1 by 2 to 0. It will be e to the power plus f df, and plus 0 to 1 by 2, it will be e to the power minus f df. So when you solve this integral, you will get 2 minus 2 times e to the power minus 0.5. So clearly e of y square of t is not equal to e of x square of t. So the second statement is also not correct. The third statement you have given that e of y square of t equal to 2. So this is also not correct because e of x square of t equal to 2. E of y square of t is given by 2 minus 2 into e to the power minus 0.5. So the correct answer for this question is only 1 is true. So option A is the correct answer for this question.